Circles. Equation of a circle. Please make note of the date and time that you are watching this video, the location, as well as the date and time. The location as well as the date and time. You want to have your Post-its handy. We're going to finger track and read and find out what can we find about this angle based on what we know. Let's start with the basic. We see that E to C is a diameter, so immediately you should trace, that's 180, and trace, that's 180. Now, we're given only one angle here, so we're going to sweep that and get out your Post-its, and I'd like you to frame that angle. We see that's an uninscribed angle. The vertex is on and the arms are in. So the inscribed angle is half the arc. So if this is 55 out here, the angle equals the arc over 2. Our angle equals 55. We don't know the arc over 2. You cross multiply and we get 110. So let's see what else we know because of that. Again, we simply ask ourselves, what can we find? That's now 110. Remember we said from here all the way to here was 180. If you take 180 and minus 110, we can get from here to here now, and that, of course, is 70. Why? 180 minus 110. Let's see what else we can find. We have an inscribed angle over here. C is inscribed. Vertex on, arms in. That's the definition of an inscribed angle. Vertex on, arms in. So I'd like you to frame angle C, please, with your Post-it notes. Inscribed angles are half the arc they grab, so if this is 70, that's the arc. This angle back here is half of 70. Of course, that's 35. So this is 35. Remove your Post-its. Let's see what else we can find. We see here, let's not overlook the obvious, that we have a central angle as well. Central angle. Central angle is equal to the arc. So there, if that's 110, back here, this is 110. This right here is a central angle, so it is also 70, which makes sense because 70 and 110 add up to 180. And then we have here triangles. So we can add 110 plus 135 plus 35. Of course, that's 145. We take that away from 180, and we're going to get 35 here, which makes sense because that is an isosceles. 2 radii make it isosceles, which means these are equal over here, which makes this is also 55. And if you add 55 and 35, we see that we have a right angle. If you look very carefully, that's an inscribed angle too, and it's grabbing the arc 180, so half of 180 is 90. Let's see what else we can find. We have an inscribed angle over here at D, inscribed angle. So get your Post-its and frame that up. we see that this grabs 180 degrees. Therefore, back here is 90 degrees. Because it's inscribed, it's half the arc. See if we can find anything else here. This angle out here is made up of a secant and a secant. Excuse me, a secant tangent. This is a secant tangent angle. And a secant tangent angle is the big arc minus the little arc over 2. Let's do physical pickup. Do we have the angle? No. So that's our unknown. Do we have the big arc? Let's sweep it and see. We have 110. It's red. Minus the little arc. Do we have it that it's intersecting? Yes, it's 70. Divided by 2. 110 minus 70 is 60. Divided by 2, that means this angle out here is 30 degrees. We have found all possible angles here. All possible angles. We started with one, and we squeezed the sponge and found everything else out. At some point today in this lesson, this thought will most likely cross your mind. Guaranteed. Guaranteed. This thought at some point will cross your mind. The thought is, that's it? In the next 15 minutes, at some point, guaranteed that thought's going to cross your mind. That's it? That's all there to it? And the answer will be yes. That's it. So this implies this is a relatively simplistic concept, which it is. Equation of a circle. Let's start with the definition of a circle. A circle is the set of all points which are equal distance from a single point. So here's a single point. Let's say this out loud and trace with me at the same time. A circle is the set of all points which are equal distance from a single point. If you didn't trace with me, I'd like you to trace now again and say this sentence aloud at the same time. There's your single point. Start here and out loud say this with me and trace at the same time. A circle is the set of all points which are equal distance from a single point. Ask yourself this, when you said the word distance, you actually traced the what of the circle. I'd like you to fill that out. When you said the word distance, you actually traced the what of a circle. Fill that out. You should have noticed when we said distance here, we actually traced the radius. So in the circle equation, distance and radius are going to be interchangeable. Let's write out the equation for distance. This is from previous lessons. Distance is giant square root, subtract the x's squared, plus subtract the y's squared. Technically, it's y2 minus x2 minus x1 squared, y2 minus y1 squared. As I've said in the past, it doesn't matter which one's the first and second point, as long as you subtract the same way each time. So we're going to interchange radius for distance, so we're going to substitute r for distance here. So write this with me. Radius equals giant square root. Subtract the x's squared. subtract the y's squared. Bring this over to the next page. In a circle, we specifically label the center point, not x and y. We call it h and k. H and k. So in this diagram, the distance equation is going to look like this. Distance equals, if we want the distance from here to here, the distance is going to equal, make your template, is x minus h, h being the center point x, but we call it specifically h. X minus h, parentheses squared, y minus k, parentheses squared, k being the y point of the center. That would be the distance equation. But earlier we substituted distance for radius. So let's plug in the radius here. So the radius equals giant square root x minus h squared, y minus k squared. We want to get rid of the square root on the right-hand side to make this equation easier to work with. So we're simply going to square both sides, because whatever you do to one, you do to the other. So our final version here looks like this. R squared equals x minus h, parentheses squared, y minus k, parentheses squared. R squared equals. That is the distance, the equation of a circle. The final version that I'd like you to memorize is when you have a circle with a center point h and k, and any point on the circle, x and y, the equation looks like this. X minus h, parentheses squared, plus y minus k, parentheses squared, equals radius squared. This is what I'd like you to memorize. This is the equation of a circle. Now there's three things we need to do with this equation of this circle. Three skills that you need to know how to work with. You need to be able to build an equation, pull apart an equation, and graph an equation. Build, pull apart, graph. Say that after me. Build, pull apart, graph. We're going to start by building the equation. Whenever you do any of this, just write out your regular equation straight from memory. You're going to be writing it out multiple times. The equation of a circle is x minus h squared, y minus k squared equals radius squared. We want to write an equation of a circle which has a center 3, 0 and a radius of root 7. So our center is 3, 0 and our radius is root 7. Remember, our center is technically our h and our k. So we're going to plug this in, x minus, pick up your h here, which is 3 squared, plus y minus, pick up your k, which is 0 squared, equals radius squared. So we're going to go root 7 squared. Now we just need to clean this up just a little bit and we'll be finished. X minus 3, there's no double negative, so we're going to leave it alone there. Y minus 0. Y minus 0 is just plain old y, so we're going to have y squared here. Now, root 7 times root 7 is root 49, which is just 7. So root 7 squared is 7. And you are done. That is the equation of a circle with a center of 3, 0 and a radius of 7. That's how you build an equation. Build. So we're done. Check. Next we need to how to pull apart an equation. So here we're given an equation. Find the center, which is our h and our k, and the radius of a circle. So now we're looking for h and k, and we're looking for our radius. We're not given either. Step 1, I'd like you to write the given equation directly underneath what we're given. So it's x minus h squared, y minus k squared equals radius squared. Circle h and circle what's right above it. Notice we swapped the sign. So our original h, we had to have a double negative in order to swap the sign. So our h is going to be -2. Our y, notice the sign did not, our k, notice the sign did not swap, so it just was a +5. And our radius, r squared, equals 49. Square root both sides. That means our radius is the square root of 49. So our radius is 7. So our center is going to be -2, 5 in this circumstance, and the radius is going to be 7. That's pulling apart an equation. Last step is we're going to learn to graph. Now, in order to graph, we first need to pull apart. That's why we learned that skill first. So I'd like you to write the equation right underneath. X minus h squared, y minus k squared equals radius squared. So we want to get our circle center, which is our h, k, and our radius. We want to pull those apart. Our center, notice that's a +5. The original equation was a negative, so in order for that to have swapped the sign, we had to have a -5 there. Here, our k is +3. If it was -3, it would have swapped the sign, which it did not. R squared equals 16. So we square root both sides. That means our radius is 4. So now we're going to graph. The center is at -5, 3, and our radius is 4. Graphing circles is actually much easier than graphing a line. Start by graphing the center of the circle. So we go -5, +3, and plot your center, and always label. Now our radius is 4, so from that point, we're going to go up 4, 1, 2, 3, 4, that's a anchor point. From the center, go down 4, anchor point, go to the right 4, anchor point, and left 4. Think north, south, east, west, anchor points. Now we're going to create a circle. So sketch from that 4 points, sketch yourself a circle. If your circle comes out slightly lopsided, don't worry. As long as it's very obvious that the radius is 4 here and that you're centered properly, you'll be fine, even if your artistic expression is not perfect. That's how you graph the center of a circle.